try again. We're good. Okay. Resonance structures. Are alternate Lewis structures in molecules with double and triple bonds. So yesterday we learned that there are these Lewis structures and they're a representation of a molecule. When a molecule has one or more double or triple bonds, in actuality that double or triple bond exists in all the possible places at the same time. Because electrons are moving so fast that we get into what we call quantum theory, and we cannot tell where they are and how fast they're going at the same time, so we just kind of have to define all of the possibilities of where they could be. Example, sulfur trioxide. We're going to draw that Lewis structure. So sulfur trioxide, 6 for sulfur, 3 oxygens with 6 each. We have 24 to work with. What's my central atom? Which one's farther from fluorine? Sulfur. We have 18. When I divide them evenly amongst the outer atoms, I have 3 outer atoms and 18. Each one gets 6. 2, 4, 6, 8, 10, 12, 14, 16, 18. And at this point, I've run out of electrons. But are all of my octets full? Oxygen, 2, 4, 6, 8. But sulfur, 2, 4, 6. When you get to this point, your only option is to double bond. And it only has to be one of them. So I'm going to pick this up right here and move it into a double bond. Now, all of my octets are full. Sulfur has 2, 4, 6, 8. All of my oxygens have 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. This is a perfectly acceptable Lewis structure for sulfur trioxide. But, because of what I was just talking about, electrons are in constant motion, and actually, this double bond is in this place, and this place at the same time. And we'll learn later in AP chemistry that it's really more like this is a 1 1/3, 1 1/3, and 1 1/3 bond. But we can't draw it that way. We can't represent it that way. So what we do instead is we draw resonance structures where you draw all the possibilities. So that's another possibility. Same thing, just the double bond is in a different place. And then there's one other possibility. So those are my 3 resonance structures for sulfur trioxide. I can't just draw one of them. By drawing all 3 of them, I'm representing that this double bond is in 3 places at one time. Kind of. The electron is traveling. Questions so far? Sergeant?
So, like, is there a certain spot, like, the electrons have to, like, be gone?
What do you mean? And these, no, it doesn't matter. Just as long as they're like lone pairs on top, bottom. Let's do another example. Ozone O3. Where have you heard of ozone before? Yeah, I know you have. Earth has that thing called the ozone layer. It protects us from the sun. So ozone is O3. It's 3 oxygen molecules bonded together. We have 3 times 6 is 18. What's my central atom?
Oxygen.
That was a trick question. I've used 4. So I have 14. 2, 4, 6, 8, 10, 12, 14. My octets are not full. My outer oxygens are fine, but my inner oxygen is not. And then, because of resonance, because this bond is kind of going back and forth between these 2 places, we have to draw it. Both ways. Okay, just one more thing I want to talk about. Yesterday, in your notes, we drew carbon dioxide. Like this. I think. 2, 4, 6, 8, 10, 12, 14, 16. Okay. No one yesterday brought this up. But is there any reason that it couldn't be this? Two, 4, 6, 8, 10, 12, 14, 16? Or even this? Okay, so for now, I would accept any one of those 3, or if you drew those 3 as resonance structures, it would be technically acceptable. In AP chemistry, you will learn about something called, I can't even think of what it's called. mind just went completely blank. Formal charge. It's called formal charge. And you assign formal charges to elements, and it helps you choose the best resonance structure if there is one. We're not learning that here. So say you're on the internet. Is there somebody at the door?
Yeah.
Is it Mrs. Tracy?
I'm not sure.
Oh, no. Are you here? Lulu, come here. You're needed. Wanted. No, no, no. Okay, so until you know which one's best, I just want you to be aware that you may go on the internet and you've drawn this, and I gave you credit, but you go look it up and it shows this. That's because in this class we haven't quite learned enough to know that this is best and why, and that's okay. So don't go Googling things, getting yourself confused when I gave you credit for this, but it's actually this. Okay? All right, you have homework to work on today? That's it.